Hello again. So, this simpler toolpath is the second operation in the list here. Just follows a single curve around this fairly complex formed shape. Okay. Now, if we open up the axis map tool now, we can see that I've already built a graph in there. So let's discuss what each of these elements mean. So to start with, the graph scale along the bottom of the map describes the distance travelled throughout the toolpath. It can also be thought of as a point of time within the toolpath as well, if that's easier for you. The left-hand scale describes the angle of deflection from the 0 point of the particular axis in question. So this would be the A6 axis. We also have control of axis E1, which is not relevant in this particular instance, although if you're dealing with turntable style controls, it's very useful for that. Furthermore, we also have access to the lean angle and the lead angle, and we'll very quickly go over what these mean. So let's build the map now, and we'll build a graph here, and we can see that it's drawn a line at the 30-degree point. So let's bring that down to the 0-degree mark. And as we use this scale here to pan across the length of the toolpath, we can see that it's pretty much pointed vertically down. So let's have a bit of a play with this. Let's introduce a bit of lean. And as you can see, the way that lean functions in this is that it is basically the amount of angular lean you've got going across the direction of the toolpath. Okay, whereas lead is the amount of angular lean that you have going along the direction of the toolpath instead. So you lean across the toolpath and you lead in or out of the toolpath, if that makes sense, or toward or against even. So let's take a look at the lead angle as well here, and we can build the map there and build the graph again. Again, it's largely along the 0 point here, so that's not a massive problem. And what we can do is if we drop this back, you can see now how the robot spindle is leaning back towards the origin point of the toolpath, versus if we bring this up now, you can see how it's leaning into the toolpath instead. So, leaning back, and as we pan across, leaning forward. Okay, so that's what the lead angle is versus the lead angle. Anyway, we've just presented a very simplified version of what goes on in the axis mapping tools here. We've obviously not covered any of the collision mapping content yet, so let's take a look at that whilst we're at it. So, to check this, we can turn on collisions, and we can check the part, or we can check the workpiece as well. So if we build the map now, we should be able to see that, oh no, there is a collision that's formed right there. This is obviously not ideal. So if we take a closer look at that, and we can see that we've actually caused that collision by playing around with the lean and lead angles, specifically the lean angle in that case. So what we can do now is we can update the toolpath accordingly, go back into the lean angle, rebuild the map with collision detection turned on, and we can see where we start to intersect the part here. So this section here, this blue region, indicates there's a collision between the part and the workpiece and the robot itself. So if we now edit this tool, this graph down here to lean it away and update the toolpath, we should now be able to play the whole thing through without seeing any kind of interaction. So again, we've got a quick and easy simulation method here. We just scroll it along like this. Okay, and we've got that same level of control in even more intricate toolpaths than this. Although I will say that the more complicated the toolpath, the longer it will take to calculate. This is just a very short 1.5 meter long toolpath. If we're dealing with a very large sculpted piece using something like a 5D by meshes or a 4D finishing toolpath, it's going to take significantly longer because there's so much more distance for it to traverse. Okay. However, with programs like that, this ability to iterate through and make changes drastically improves your chances of being able to generate a working toolpath. In the next video, we're going to take a look at a more complicated toolpath and the amount of work that's required to be able to get it to traverse successfully without causing any impacts or problems. See you then.